This question is testing you on the area under graph under integration. So if you look, the diagram is actually very simple, and yet they give you 11 marks. So where does the 11 marks come from? Okay, so this will be the shaded area. And then before you do anything, you make sure you dot down any intersection point. So if you have watched my basic video concept of area under graph, I will have told you, you need to dot down. So the purpose of dotting down is to see an enclosed shape. So you need to have some plan first. In this question, if I would like to have the shaded area, I will need this area under the curve. So I'm planning out first. So this is the area under the curve. Remember, the area that's under the curve always stick on the y-axis. So I will need this blue area. Then I will be subtracting this shape. This shape is a trapezium. So there are two ways of getting the trapezium. You can either integrate the straight line, or you can use the trapezium formula, the half times height a plus b. But whatever is it, you will need the coordinate of b. So after you plan out that you will need the blue area, the blue area is quite easy. The blue area, if you do a direct one, is just integrating the curve. So you just need to integrate the curve from 2 to 0. Okay, so if you've gotten the correct formula, it will have been this formula. So it's the one that you integrate like this that will give you a long. So if you apply this formula, then you will get the area under the graph. Okay, because the question is asking for exact area. So when you're processing the area under curve, do not press out the long tool. Okay, so this one, I leave it to you to try. If you use the correct formula, then you just do a top minus bottom. But do not press out the value. You will get a chain of decimal. And the question is asking for the exact area. So you do not need to press out in decimal. So there are some amount of logarithm that you need to do. If you look carefully, I changed my 8 to 2 cube so that I can have a constant, I have a same logarithm. So I'll be dealing with ln 2 for this part. Okay, so that the plan is area under the graph subtracting the trapezium. So area under graph is settled in the blue part already. Now, the difficult part is actually to get the coordinate of B. So in order to get the coordinate of B, I need to get the tangent to the curve. So the coordinate of B is the one that a lot of people will get stuck. Most of you will be, how am I going to get the coordinate of B? So you need to get the equation of tangent. So you need to go back to your steps of equation of tangent. So the steps of equation of tangent is you need to get a dy dx. You need to put in the value of x, and this will be your m. The tangent will be mx plus c. So you need to get a dy dx, put in the value of x, and then using the coordinate here, you get into your mx plus c. So that will be the equation of tangent. And with the equation of tangent, B is the y-intercept. That's why we substituted x equal to 0, and you get the coordinate of B. So once I get the coordinate of B, I prefer to do it by the trapezium formula. So where you get the two heights, and then this is the so the two parallel lengths, and this will be the height of the trapezium. Okay, so that's how I got the area of the trapezium, and I just subtract away and I leave it in the exact form. So I'm not going to punch out the calculator. I just leave it in the exact form.